We're now on the section that's called inequalities. We're going to talk about how to use inequalities to help us solve our problem. So I see here that I start at -7 and I'm going to 4. So notice this is basically taking my x-axis, so all of my numbers going from left to right, and putting it on a number line. So my verbal description, I know that this solid line means that all these points are filled in. So this means all numbers between -7 and 4. So it's going to be all numbers between -7 and 4. Mathematically, I'm going to write it like this. So I know these are my x values because it's going from left to right. I'm going to write my x just like this. And I am going to sandwich it between two signs. Now this sign means less than or equal to. This should be a throwback to middle school, but it means less than or equal to. And I'm going to write on this side the number that's lower than all of my possible x values. Remember, x can stand for any number in here. I know that my x has to be between -7 because that's the lowest it can possibly be. That's my lowest barrier. And what is my highest number? My highest number is 4, so I'm going to write that right over here. So this is saying that x has to be greater than -7, or in other words, -7 is less than all of my possible x values, but my x value cannot be higher than 4. So you should probably memorize this format right here where we're filling in numbers. This is going to be a notation that you see a lot, and it means that x or any number can be between -7 and 4. Let's try another one. On this one, I'm noticing something a little bit funky with this arrow. So arrows mean that it keeps going and going and going forever, right? All the way to infinity. So that means that this can be verbally or in words. I would say that this means all numbers, and I see it's going to the right, which means bigger. I'm going to say all numbers greater than or equal to. What's this number right here where my number starts? It's 6. So this graph is showing me all possible numbers that are greater than 6. Mathematically, remember, I'm going to start with my x. So x, all of the numbers over here have to be greater than, because x is bigger than, so the open end wants to go toward my x, greater than or equal to 6. We're going to do one example together on one going up and down. Remember, up and down always means y, so be thinking about my range. What if I had, this is a graph of temperature. So this is Texas, right? So I'm going to say that in the next month, I hope that my temperature is going to always be between 90 and 70. I'm going to fill that in. So in words, or my verbal description, I would say all numbers or all temperatures between 70 and 90. Another way to think about that in terms of math, I'm going to set up my x. I'm going to set up my boundary saying that x is less than or equal to each of those numbers. And I know that my lowest one, so the one I want to write on the left side, is going to be 70. The one on the right side is going to be 90. So this is how we use inequalities to help us with solving. This is a little bit confusing. Also, something I just did wrong. I just realized I should not write x because what letter am I talking about here? Y. Y. So I should write that y. So I know that y is my unknown number right there. I know this was a little bit confusing, but I wanted to give you guys a quick crash course on something we should have talked about in middle school before we jump into these next two examples. So these directions say, use inequality notation, which we just learned in sentence form, to represent the domain and range. So my domain is going to be all my possible x values, and range is going to be all my possible y values. So I'm going to start with domain. I know that for domain, I am going to connect my point to my x-axis, just like this. And I'm going to start at the farthest left point. I see this is the first time my pen is going to hit anything on my function. This is the farthest left. I'm going to keep going. It looks like my function ends right here. See this dot at the end? This is the end of my function. So I'm just going to connect it right here. So I see I went left 1, 2, 3, 4, 5, 6. So this is -6. And I went all the way to 1, 2, 3. This is 3 right here. So my domain is going to be all numbers between -6 and 3. My range, on the other hand, actually, we're going to stop really quick. We're going to do my inequality notation. So I know that x is going to be between, remember, set this up, what's my farthest to the left? -6, and it's also going to be at 3. My range, on the other hand, I'm going to start at the bottom. I see this is my bottom point, and this point right here is at the top. So don't let it fool you. It's already on that y-axis. So I see this one is -1. That's the highest point on my graph, right? Nowhere does this little squiggle go above this point. This point is the lowest. So it's from -1 and 1, 2, 3, 4, 5, all the way down to -6. So it's all numbers between -6 and -1. So I can write that. I always start at the bottom. I'm going to set up my y is less than, because I know I'm working with my y values for the range. And it's going to be between -6 and -1. This is my final answer for the range. I also know that a closed endpoint, so we're going to pause. Closed endpoint looks like this. It's a circle that's filled in. It means that the value is included. So that means that I'm going to include this line underneath. And I know that this also means or equal to, because it's included. So whenever you see the little line underneath your inequality, that means that your point is included. If it is open, it's going to go like this. There's going to be no line underneath. It means that the value is not included. Okay, we're going to take a quick pause on these. You have plenty of time left to talk. This example right here, you might want to ask questions on. I'm going to have it worked out on the board, but I want to give you guys a chance. So try these next two examples. Again, please make sure to ask me if you have any questions.